Okay, this is section 3.4 of the textbook, applying Pythagorean theorem to triangles. Not in context necessarily, but just in questions that have missing side lengths. So the first show you know says determine the length of the hypotenuse given the two legs that are there. So I'm going to redraw my right triangle. I always like to do it this way. I don't know why. 6 is one leg, 10 is the other, and the missing leg or the hypotenuse is x. So there are two methods we can use to solve this. The first method is to simply draw our squares onto all three sides of that right triangle. And inside all of those squares, we could write the area. So this is 36. This would be 100. And the area of this square, which is the sum of the two squares attached to the legs of a right triangle, make that area of the unknown side length 136 centimeters squared. That's its area. Okay. Now we know that 136 is not a perfect square, so what we would then do is say, well, what two perfect squares does 136 fall between? Well, the square root of 121 is 11, and the square root of 144 is 12. So we know that it's going to be 11 decimal something. That's the length of the hypotenuse. But the level at which we can approximate it, it depends on how close it is to either. It's 8 away from this, and it's 15 away from that. So a good estimation would be roughly there, which would probably make it about 11.7. So I would say a good estimation is 11.7-ish, right? Don't put equals because it's not equal to that. It's approximately that. The actual length, though, if we wanted to say what is it exactly, the exact length would be the square root of 136. The approximate length is about 11 decimal 7. Just double check with a calculator. 136 square root. It is approximately 11 decimal 7. Okay, if you round to the nearest tenth. So the first method you could use to solve that problem would be just simply to draw it. But there is a second method, and that's to use the theorem itself. So if we think about leg A and leg B and leg C, Pythagoras said if you square the first leg, or square 6, you get the area of square A. And if you add that to, if this is leg B, the area of square B, you add those together, you will always get the area of square C, or A squared plus B squared equals C squared. So if you substitute what you know into that formula, you would get something that looks like this. You get 6 squared plus 10 squared equals C squared. Simplify it, and you get something that looks like this when you simplify it. 136 equals C squared. And once you get to that, we don't want to know the value of C squared, we want to know the value of C. So algebraically speaking, whatever you do to one side of the equation, if you do it to the other, you maintain equality. So the idea of square rooting this side and the idea of square rooting this side will maintain equality. The square root of C squared is C. And as we said before, the approximate square root of 136 is 11.7. I'll use a dot above my equal sign to show approximately equal to. So we can do it the same way without drawing it. We could just substitute it into our formula, either leg A, B, and C. One of them we don't know, and we can simplify it to find out. All right, so that's the first show you know. The second show you know says determine the hypotenuse. Didn't we just do this one? It's the exact same question. Well, that's bizarre. Okay, hang on. So the second show you know should look more like this. So this time we're not searching for the hypotenuse, we're searching for a missing leg. So the same two methods that we used in the last question could be used here. The first thing we could do is draw squares onto each of them. Inside each of those squares, calculate the area. So if the side length is 20, the area of this square will be 400. If the side length is 52, the area of that square will be 52 squared. So 52 times 52 will be its area, which will be 2,704. And what Pythagoras said is the area of this square plus the area of this square, or the two legs, will equal the area of this square. So 400 plus, I don't know, will equal 2704. So really this is kind of like a one-step algebraic equation. If I subtract 400 from 2704, I'll get 2304, which is what this must be. Because 2304 plus 400 is 2704. So now we know the area of the square attached to the missing leg, and its square root will be its, I hope I did this right, yeah, the square root will be its side length. Now, we probably can't estimate the square root of 2304. Probably not. So this is one that we're not going to use mental math for. We're simply going to take our calculator and know that the exact length of that is going to be the square root of 2304, or the approximate side length of that will be, oh, will be 48. It's a whole number. Look at that. So we could have probably used a guess and check for that, but the square root is 48, which means the missing leg length is 48 units long. Okay? Does that make sense? Hopefully.